All right, so I wanted to do a little bit of an example problem to follow up with what happened in lab. So this is based on the lab question, and at the end of lab we do a free body diagram for the system. And what I want to do now is actually draw the forces and solve a problem like this. So go ahead and read the problem, and we're going to set it up now. By the way, I want to change this to a capital M and this to a little m. So now let's draw the free body diagram. We're going to have the normal on big M due to the surface, the weight of big M due to the earth. We push with force F. And then on little m, we have the normal on little m due to the surface. We have the weight of little m due to the earth. Now, what actually pushes little m is not F. F isn't touching little m. It's touching big M. So the force that pushes little m is, in fact, a contact force it's on little m, and it's due to big M pushing it. Now, we learned in lab today that for every action there's an equal and opposite reaction, or if big M pushes on little m, then little m pushes back on big M with an equal and opposite force, just like we saw with the compression. So we draw those two forces like that. So we have this force here and this force here. They are equal and opposite. Those are all the forces that we have in our system. Now, what we want to do is we want to determine the acceleration of the forces, of the boxes, and the value of this contact force here. Do we do anything new? No. In fact, we're going to use exactly this approach that we used here. So go ahead and get that out if you don't have it. So we've drawn a free body diagram. We have no forces in x and y, or at angles. We do have forces in x and y, but no angles. So what we're going to do is we're going to set up equations in the x and in the y direction. For big M, in the y direction, we're going to have the normal minus the weight. And of course, these forces balance. Now, in the x direction, we're going to literally read it off the picture. So I have the force applied minus F on big M due to little m. These forces don't balance. We're going to assume the surface is frictionless. And the effect is that big M accelerates. When we follow a similar argument for little m, we're going to have that the normal on little m cancels the weight, as before. But now, for little m, we have F on little m due to big M makes little m accelerate. So now what we're going to do to kind of finish up here is we're going to plug in our numbers, just like it says to do in our procedure. So we have 200 minus our unknown force equals 4 kilograms times A. And then we have F on little m due to big M equals 1 kilogram times A. So our problem is we actually have to solve an equation that has two variables and two unknowns. So I want you to try to do this tonight for homework. And if you can't, that's exactly the example problem that we're going to be doing in class tomorrow morning to follow up with our forces lab.